Lesson 10-7, modeling and curve fitting. Different types of functions can be used to model different kinds of data. You can use the equation or graph of a data set to determine the type of function that it represents. So we've gone through linear and quadratic. We've also gone through exponential. So the differences and ratios can be used to write the functions to represent that data. When the x values are increasing at a constant rate, that means it's increasing by 1. The differences of the successive y values are called first differences. If I subtract my y values, I should get an answer. That would be my first difference. Now, if you find the differences of your successive first differences, it means if you take your answers of your first, like if you subtract your answers of your first subtraction problem, those are your second differences. That will make more sense once we see some examples. So now what do you do with that information? Linear is always in the form of y equals mx plus b, and the graph will be a linear line. So that means you have a constant slope, and your y's increase by the same amount. So you're adding the same number each time with the first difference. Now the quadratic, the format has an x squared in it. The graph is parabola shaped. And the exponential, your format is y equals a times b to the x power, and it gradually gets bigger or it gradually gets smaller. Now linear, the y changes by a constant amount per unit interval, which just means you are adding the same number each time, whether it's a positive number or a negative number. So you can be using the first difference, and if the first difference is the same, it's linear. For a quadratic, you're going to find the second difference, and the second differences are going to be equal to each other. Half of the second difference is going to be your a. And then it says your exponential ratios are equal, so the common ratio is the base b of the function. That means to find the ratio, you just take one y value divided by the previous y value. An example, look for a pattern in the data table to determine the kind of model that best describes the data. Then write the function. So here, my x's are increasing by 1, which is what we want to see. Now, if I subtract, so I have -4 minus a -1, that means this is a -3. And then if I take -7 minus a -4, I get a -3. And -10 minus a -7 gives us a -3. And -13 minus a -10 gives us a -3. So my first difference is -3. That means this is linear. And now we can use that to write our equation. We know that it has to be in y equals mx plus b format. We found our slope. Our slope is -3. So if I put -3 in for m, I need to choose an x and y coordinate so I can find my b. And it doesn't matter which one you choose. I'm just going to choose this first one. So if x is 5 and y is -1, I can now solve. So this is -15 plus b equaling -1. Add 15 to both sides. I now have b equaling 14. So my function would be y equals -3x plus 14. Next, we'll determine this model here. Actually, this was your A and B, which we just did all on that one slide. So our example, the second example here, determine that model here. Again, my our x's are increasing by 1. That's our first step. Check for that. Here, I can see that get from here, I'm subtracting 3, subtract 3, subtract 3, subtract 3. So since these are all the same, I know that this is linear. And then we're going to find the equation. So I have more space here. So we knew that this was linear. So it would be y equals mx plus b. I'm going to choose, we found that our slope is negative 3. I need to choose an x and a y so I can find my b. Now for this one, I already know my y-intercept. Because when x is 0, my y is going to be 6. So thankfully, I could just do that. But to go through all the steps, let me choose another point. Let's just choose, I can use 0 and 6. So if x is 0 and y is 6, negative 3 times 0 is 0. 0 plus b is b. B is going to be 6. So my equation is y equals negative 3x plus 6. Example 2, over here we're going to be finding a model by using the second difference, which we said a second difference was going to be quadratic. We're going to look for the pattern. Here these are increasing by 1s. It's just like the linear ones, that was the same way. Now our y's, here I subtracted 10, I subtracted 6, I subtracted 2, now I added 6, and now I'm adding 6. You can see that they are all different. So now my second difference, I just take negative 6 minus a negative 10, which will give me 4. Negative 2 minus negative 6 will give me 4. 6 minus a negative 2 would give us, actually this is not a positive 6, this is a positive 2. So it would be 6 minus a negative 2, or minus 2 would give us 4, and then 6 minus 2 would give us 4. So our 4 here is what we're going to use to now use to help us find our A. If I go to the next slide, we know that this is quadratic because we were able to find the second difference. And quadratic needs to be an ax squared plus bx plus c. And we were told from our table at the very beginning of the lesson that whatever we get for our second difference, half of that is going to be our A. So since we had 4, half of 4 is going to be 2. So we can put 2 in for A. We need to find our B and we need to find our C. So to do that, I'm going to put this would be our x squared plus, we don't know our B, so I'm going to put a B here. This would be an x plus our C. And our C in a quadratic is always our y-intercept. When x is 0, what is our y? Here we can see right here, when here when x is 0, y is negative 6. So I can put a minus 6 here. And this is equal to y. So now all I need to do is choose a coordinate from the table that I can plug in for x and y so I can find my b. I'm going to choose, let's just choose this one. So 3 is 0. So if I put a 3 in for x, my y is 0. So this would be b times 3 minus 6. 3 squared is 9. 9 times 2 is 18. Plus 3b minus 6. This has to equal 0. 18 minus 6 is 12. 12 plus 3b equaling 0. Subtract 12 on both sides. I now have negative 12 equals 3b. Divide by 3. B is going to equal negative 4. So my equation would be y equals 2x squared minus 4x minus 6. Moving on to the next example. Here we check the data, adding 1 each time. Here, the common difference. So I'm subtracting, actually subtracting 4. Here, I'm subtracting 12. Here, I'm subtracting 20. Here, I'm subtracting, looks like 28. Then if we find the second difference, here I'm subtracting 8. Here I'm subtracting 8. Here I'm subtracting 8. So we would have our second difference at -8. So we know that the second difference works. So this is a quadratic. And our second difference was -8. So if I take half of -8, that's -4. So our A is going to be -4. We need to find our B. And our C, we don't know our C because we don't know what our y-intercept is going to be. And actually this one, if I look carefully, my y-intercept, it does tell us the y-intercept. When x is 0, y is 2. So I can put a positive 2 here. Now I need to find my B. And I'm just going to choose a point. I'm going to choose 1, -2. So when y is -2, and -4 times 1 squared plus b times 1 plus 2. This will give us -4 plus b plus 2 equaling -2. Here we got -2 plus b equaling -2. Add 2 to both sides. B would equal 0. So that means I don't have a b coordinate or a b term. So that would be y equals -4x squared plus 2. Example 3, now you're going to use ratios to solve this one. So this would be exponential. So again, my x's need to increase by 1. And then my common, since I know this is, if I look at the pattern here, it starts off huge and then it gets down pretty small pretty quickly. If I take 100 divided by 400, I get 1/4. 25 divided by 100 equals 1/4. 6.25 divided by 25 equals 1/4 or 0.25. And then 1.5625 divided by 6.25, that equals 0.5 or 0.25 or 1/4. So this is exponential. And it has to be in the format of y equals a times b to the x power. So we're going to write our function. We found our b. Our b is 1/4. And then we're going to use a point in the equation, in the table, to substitute for x and y. So I'm going to use 4 and 100. So if y is 100, equaling a times our base, which is 1/4, raised to the 4th power. Solve for a, 1/4 to the 4th power, so 0.25 raised to the 4th power would give us an answer of 1/256 equaling a 100. To get a by itself, I multiply by 256. 256 times 100 equals, our a would equal 25,600. So my equation would be y equals 25,600 times 1/4 raised to the x power. Next example, look for the pattern in this one and determine the best model. We know this is going to be a common ratio. So to verify that, you can see we start at a smaller number and it increases very rapidly. So this one I'm multiplying by 4 times 4 times 4 times 4. So we have a exponential. in the form of y equals a times b to the x power. I'm going to choose a point. I'm just going to choose 1, 1. So when y is 1, a to the b was 4, raise that to the first power. So this will give us 4a equaling 1. Divide by 4, a would equal 1/4. So our equation would be y equals 1/4 times 4 to the x power. Next, the data here and then write the function. So increasing by 1. Here, this is increasing by subtracting 3, subtracting 6, subtracting 12. If I did this one is decreasing by 3, decreasing by 6. We know it's not second difference, and it's not first difference. What if we multiply this by 2, this times 2, and this times 2? That matches up. So this is exponential. And then it has to be in y equals a times b to the x power. I'm going to use this point for write my equation. So now I have -3 equaling a times b. We said b was 2 raised to the 0 power. Anything to the 0 power is 1. So we have 1a equaling -3. So my equation would be y equals -3 times 2 to the x power. Next, curve fitting. You can use a graphic calculator to find a regression equation for the set of data that is approximated by a function. This process is called curve fitting. The coefficient of determination, that's what they mean by this r squared, indicates how well the function fits the data. So the closer r squared is to 1, the more accurate it is for that data set. Data is entered into a table on a calculator, and the regression is done, and it will come up with the equation for you. So the table shows the scatter plots and graphs of linear, exponential, and quadratic functions. Which type of function is the best fit for the data? So here, if you compare our r squares, the one that's closest to 0, or closest to 1, is actually this one. And because that one's closest to 1, we would say that this would be more of a quadratic function. The points are the same in here, but if you do a linear line, that doesn't match up with the points you have. The exponential looks very close, but you can see the quadratic. This one lines up pretty much with the points that you have. We're going to go through some examples here with that. Here it says the table shows the number of households worldwide that subscribe to a video streaming service. Write a model that fits the data. So the first thing we need to do is we're going to enter the data into our calculators. So to do that, if I grab my calculator here, you're going to hit the stat button. So if you hit stat, then we're going to go over to edit. And it says let the year 2007 be 0 and enter the years since 2007 to list 1 and the number of households in list 2. So here we have everything that you would need. So if I hit enter, and then we're just going to type those in, hit 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. We go back to here, you can see that our table here and then our numbers, those should match up with what we have here. So go over to list 2, we have 8, 9, 12, 19, 23, 33, and 44. Once you have the data entered into your calculator, we're going to make a scatter plot. So to do that, we need to turn plot 1 on under the stat plot menu and choose the scatter plot feature. Then we're just going to hit zoom and then zoom stat to show it. So here on our calculator, we need to hit second y equals, because it says stat plot here. You need to turn this first one on by hitting enter. Turn it on so the black box is there. And then we want to choose this first one. So this first one is a scatter plot. And you want to make sure that these are list 1 and list 2. From that point, now if I hit zoom, zoom stat is number 9. So if I scroll down and zoom stat number 9, you can see my points, my graph, very similar to what they have in the picture here. Here's my scatter plot. Now step 3, find the regression equation. As the data appear in the form of curve, you conclude that a linear regression is not the best model. It could be exponential or quadratic. So to determine that, we're going to have to test both of them. So to do the exponential regression, we're going to press stat, calculate, and then select exponential regression and press enter. So if I do that, grab my calculator, we're going to hit stat, go to calculate, exponential goes all the way down. Here's exponential regression, hit enter a second time. Now you can't see my r squared, so I need to turn my diagnostic on. To do that, I hit second on, or actually not on, second 0. That's where catalog is. Go all the way down to diagnostic on. Hit enter a second time. When it says done, then if we go back to stats, calculate, exponential was number 0. Hit enter. Now you can see the r squared, which is 0.987. So 0.987. Then if we go to, let's go to the same thing here. So now to find the quadratics, we're going to do the same thing. Going to hit stat, calculate, but go to quadratic, which is number 5. Hit enter, and it says our r squared is 0.996. 0.996 is bigger than the quadratic. So we're going to be using that one as our equation. So to do that, if I grab my calculator, it tells my equation has to be my A, my B, and my C. So my A is going to be, and we're going to do it to the nearest 10,000, or nearest, let's see, 3 decimal places. So thousandths place. So we would have 0.940 x squared plus 0.321 x, and our C is plus 7.952. Or 7.952. Now you'll see that on the slide here, my answer is a little bit different. And the reason why our answer is a little bit different here is because if I went back to the original problem, I actually didn't include these next two here. I didn't include these 2 points. So if I go back to my calculator, go to stats, edit, I need to continue going down. So I need 7 and 8, and then I need to put in 57 and 75. Then if I hit stat, calculate number 5, you would see that there's my 1.0 0.076 x squared minus 0.439 plus 8.485, which is what they have here. So this would be the correct one, not this one, because I was finding I didn't put the last 2 points on there. Okay, so if you don't put all the points in your calculator, it'll give you the correct equation for the points that you put in there, but if you change something from the original problem, it will affect your overall answer. Let's try another one. Here you can see that the graph part. So last thing is to graph the quadratic regression equation. So to copy the quadratic regression equation to the y list, press the y equals, and then vars, and then statistics. So if I go here, if I go to y equals, I click vars, I choose statistics, which is number 5, go to EQ at the top, choose number 1, puts that equation in there, and then if I hit graph, you can see my line that goes up there that is pretty much accurate on my points that I have listed there. So now let's try the second one here. So we'll go to our calculator. We need to hit stat, edit. And for this one, since we're not dealing with years, I'm just going to put down, first I'm just going to clear everything I have in here. I'm going to put the points exactly the way it is. So 0.5, 1, 1.5, 2, and 2.5. I believe that last one was 2.5. Okay. Then my y's are 12, 32, 58, 88, and 122. So I'm going to hit stat, calculate. I can see that to determine which one it would be, I'm increasing my x's by 0.5 and my y's are increasing pretty quickly. So I think that could be exponential. It would not be linear, so or it could be quadratic. So let's do the quadratic first. If I hit 5 and hit enter, I have an r squared of 0.9999, which is very, very close to what we want. So if I rewrite my equation, this would be y equals 9.143 x squared plus 27.771 x plus or minus a 4.4. So that would be if we used the quadratic. If we tested the exponential, grab our calculator here and hit stat, go to calculate. Exponential was number 0. Hit enter. And we see that it's 0.95. Because it's 0.95, that's smaller than 0.99. We know that it is quadratic. You can see our equation here. If I go to the next slide here, it's multiple choice, which was close to letter B if you round it to the nearest tenth. Now it says that the race car continues to accelerate following the same trend. Predict the speed at 3.5 seconds, round to the nearest kilometer. If I take our equation here, and if we go back to our table here, the time is our x. So if I put 3.5 in for x, I can determine how fast that would be. So if I were to go back to my calculator here, And if I go back to my graph, so let me go back to y equals, I'm going to clear this one, hit vars, number 5. I gotta go back to stats, calculate. I need to go to quadratic, because it is quadratic. It's gonna put it in whatever my last one was. So I want to put this one in. So now y equals vars, number 5, statistics, go to EQ, number 1, puts that in there. Now if I hit graph, there's our line. And now if I do second trace the value, number 1, when x is 3.5, it would tell me how fast it would go. So that would be 204.8. This is to the nearest kilometer. So this would be 205 kilometers. And this would be kilometers per hour. And our last question here. It says the table shows the number of immigrants to the U.S. from Asia for each decade. Let X be the number of decades since 1900. And so what we want to do is write the equation, round to the nearest hundredths, decimal places, and then use that to predict to the nearest tenth how many immigrants there would be in 2020. So the first thing we need to do is enter the data into our calculator. So I go to Stat, Edit. We want to clear what we have in here. And 1900 is 0. So I hit 0. And each decade would represent, so 1 decade, so that would be 10 years. So every 10 years, so we would have 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, 7, 8. Let's see, how many do we have? So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I gotta go to 10. And then the y value, or L2, would be our immigrants in millions, so 0.06, 0.11, 0.11, 0.12, 0.19, 0.28, 0.49, 0.82, 2.54, 4.98, and 8.23. If I do stat, calculate, I believe that this would probably be more exponential than anything else. So let me check. Let's think it's exponential. So I go to 0, hit enter. Gives us r squared of 0.938. And if I want to check if it could be quadratic, do stats, calculates. Quadratic would be number 5. Hit enter. See, our r squared is 0.92. So it is exponential. So I'm going to go back to that. So stats, calculates, number 0. Equation here to the nearest hundredths of 2 decimal places, this would be y equals 0.04 x squared plus 1.63 x, and there is no, actually, this was exponential, so this would be our a was 0.04 times my b, which was 1.63 raised to the x power. So to predict the number of immigrants in 2020 or 12 decades after 1900, I would just have to put 12 in for x. So I'd have y equals 0.04 times 1.63 raised to the 12th power. Now if I do that on my calculator, 0.04 times 1.63 raised to the 12th power gives us an answer of 14.07. To the nearest tenth would be 14.1. And this would be in millions. So that is our lesson on modeling and curve fitting.